reactant problems, make sure you've got them in front of you, and you can work through this at the same pace as me, and you can write as we're going, but make sure you follow what I'm saying. It's very, very similar to what we've been doing up to now, with a little twist in the tail here and there. So I'm going to do a couple of easy, I'm going to do one easy one and one harder one, okay? So I'm going to start off with this easy one. So that we just do as we did before. Can you see the pencil okay? Just nod if you can see the pencil okay. Yeah? Okay, see that right? So we write out the equation as we did when we were doing all the other questions we've been doing. So it's calcium oxide reacts with water to give calcium hydroxide. Please do write out the equations. Then just as before, we write out our grids, and that first row, we write out the molar ratios from the equation. This one's dead simple though, because there's no coefficients, there's no numbers in front of the substances, so it's simply 1 to 1 to 1, just like before. Right. Then we plug in the information in the table. So Julian, what would be the first thing we plug into that table? What information do we know? Right, so the mass. In what units do we use? Always. Good. Right, so let's plug that in. So we've got the mass here. It's asking us what mass of calcium hydroxide is made when 10 grams of calcium oxide react with 10 grams of water. Now, do you see how this is different from the problems before? Before, we were only given one substance. We worked everything else out from that one substance. Here, we've been given two substances. So now we've all got to that point. Can I ask you to drop your pens? And this bit I want to walk you through. Yeah. If you just move to if you just sit next to Taylor for a second, or move so you can see them, they'd be much easier for you to do from over here. If you just for now, or you can sit at the back next to Hanya. That'd be good. So something like that. To find somewhere to sit where you can see, or there if you want to. Is that okay? You can sit there if that's easier. No, yeah, go on then. Can you see okay? Can you see all right? Okay. Right. So, yeah.
Yeah.
No.
Okay.
Yeah, it's not in here. So, no. Right. Right. So we've been given mass of calcium oxide and water. So you can have ice front to this bit, so you know exactly what it is that we're doing. So just like before, we can work out moles. But the problem is we've got two substances here. So how do we work out how many moles of this we get when we've got moles of calcium oxide and water? Now, the thing we need to think about is, like, if I ran a shoe shop and I have all ice front, and some people aren't listening. If I've got a shoe shop and I buy in some shoes and I get my order comes in, I've got 57 pairs of 57 left shoes and 43 right shoes. How many pairs of shoes have I got? 43. Tell each other, nice and loud. 43. It's really easy, isn't it? That's what we're doing here. So I've got more of one thing than the other, and the one that there's less of is what we call the limiting reactant. The limiting reactant is the one that decides how much product we've got. It can be very simple, and this example will be very simple, like the shoes example we just did. But it could be more difficult. So the example I'd like you to think about, I'll have eyes concentrating on me, please, so people are looking a bit distracted. So now I'm running a table shop. I make tables for a living, and I order some table legs, and some table tops. Let's say I order, I'll do it on here so everyone can see. I'll order 360 table legs and 100 table tops. How many tables can I make with that kit? Have a discussion. Given that every table needs 4 legs, remember. Discuss it, agree. If you're struggling with math, 360 divided by 4 is 90, if that helps. Alright, and your combined answer is in 3, 2, 1? Right, you've all got the idea, right? So, do you see how it's not always the smallest number which is the limiting one? It depends on the coefficients. Depends on the number in front. But when it's 1 to 1, it's dead easy, like 1 left shoe, 1 right shoe. Let's work through this example, then we'll do a more difficult one. So if we're not sure what to do in chemistry equations, what do we work out? 3, 2, 1? Right, so let's do that then. So we write down then the formula mass. Those substances, calcium oxide is 40 add 16, which is 56. and water is 18, 2 hydrogens and 1 oxygen. So work out the number of moles, like before, by doing, and this is someone can do the calculation for me, 10 over 56, 0.17, 0.18, we're rounding up, I think, so 0.18, thank you. So is it 0.17 with the dot over the top?
No, but there's a dot on the end. 0.17 and a dot on the end.
Dot on the end? On the 8? Oh, right, okay. So it's 0.18 if it's rounded up. And then the water is 10 over 18, please, which is? 0.5 for a coaster, 0.56 if we round up, please. We must round up. In your calculator, it will say 0.5 dot, but really that's 0.55555, which we round up to 0.56 in exams. And so, which of these numbers do we use? If I had 18 pairs of left shoes and 56 pairs of right shoes, well, the limiting one is the 18, isn't it? The 0.18. So what I want you to do is to underline that as the limiting one and put a bracket around that one. Now we can work out what the limiting reactant is dead easy, like we've just done. But I now need to teach you the way that the exam board insists that you do it. And they insist that you work out how much product you could get from either of those scenarios. Right, so if 0.56 was the limiting reactant, you'd end up with 0.56 moles of calcium hydroxide, right? And if 0.18 was the limiting reactant, you'd get 0.18 as the amount of product, because they're all 1-to-1 ratios. Do you see what I've just done there? I'll do another one. So 0.18 would make 0.18, and 0.56 would make 0.56 because they're 1-to-1 ratios. So what we've got to do in the exam, and the exam board insists on this, we've got to highlight the one which is the smaller of the two numbers here. So that's the smallest one, and that's how many moles of calcium hydroxide we can make, and we make it from the limiting reactant, which is the calcium oxide. We multiply that by the MR of calcium hydroxide, which I think is 74, but someone can just confirm that for me. And then we multiply, just like we did before, 74 times 0.18, and that's our expected amount in grams. What's that, please? What sum is that? 13.32. A bit louder. 13.32, and that's how we do this. Okay. So shortly you'll do question 2, which is identical to question 1, really, and so is question 3. So we're going to flip over the page, and we'll do question 4 together, which is a tiny bit more difficult. And we're going to do exactly the same process. We're going to think about, this is slightly different, where this is where we've got a bit like when we had the table where we've got 2-to-1 ratio. So write out the equation just like before. So 2 lots of sodium, 1 lot of fluorine goes to 2 lots of NaF. The next thing we write is what? 3-to-1 ratio. Got a ratio. Show the examiner we understand there's a 2-to-1 ratio, which is important in this sort of example. The next thing we write is what, Xavier? Next thing we write is in grams. We write this every time, no skipping it, which is 2.3 grams of sodium and 2.85 grams of fluorine. The next thing we write is what, please, Sonia? Formula mass of everything. So formula mass of sodium is, don't forget we put a box around it just to make sure we don't accidentally times by 2. Hey, Sonia? Was that you? Someone was doing that last time. I can't remember. So it's 23. Fluorine is 38. Sodium fluoride is 23 add 19, which is 42. We work out the number of moles, if someone could do that for me. So I'll do the first one myself, which is 0.1. But fluorine 2.85 divided by 38 is what, please? 0.075. Right, so we've now got to consider how much product we could make from either of those scenarios. So this bit I'll have eyes front, the pen's down. You can catch up the writing in a sec. So from fluorine, we could make how much sodium fluoride? Bearing in mind it's a 1-to-2 ratio. Tell your partner, please. Tell your person next to you. How much sodium fluoride could I make from this amount of fluorine? Discuss. Darcy? 0.15, you just times it by 2, yeah? So you would get from there 0.15. How much sodium fluoride could I get from 0.1 moles of sodium, please? Tell each other. Sky? Thank you. 0.1, so we do that. And then how do we decide which one of these was the limiting one then? The smaller one, so put a ring around the smaller one, put that in brackets, underline the limiting one and highlight it for the examiner just by saying limiting or something like that. But spell it right, I spelled it really weirdly, limiting. And then we work out the mass of sodium fluoride by doing what, please? Tell each other. Okay, so Maddie, please. How do you work out the number of moles? Given that we've got, how do we work out the mass from the information we've got over here? So you pick the wrong operator, it's multiplied by, so mass is equal to mR times moles, remember. So it's mR times moles, which is 4.20 grams, and that's the answer, that's how we go about it. We highlight to the examiner what the limiting reactant is and how we've worked it out, and then we get up, that's our final answer, put a big ring around it. So can you go back and do question 2, 3, 5 and 6, please? Thanks.